we want to integrate sine 2x divided by 1 plus cosine squared x dx. Any thoughts as to what the substitution should be? I mean, if you have to pick, what would you pick?
1 plus cosine squared x.
We want to pick the entire term, okay? What is your?
Sarah.
Sorry. Okay, Alison.
Just sine x.
Just sine x. What are you looking at sine x?
It's
Okay.
like you, well, maybe,
Why not?
maybe not just sine x, but sine.
Why not? What else?
1 plus cosine.
1 plus cosine x. Okay,
Just cosine x.
just cosine x. Any other options? Okay, good enough. Which one should we pick out of the 4? Let's start with Sarah. Why did you pick 1 plus cosine squared x?
Well, if we do the derivative of it, it'll be the chain rule. So it'll be similar to the one on the top, which is sine times 2x. So it'll equal -2 sine 2x. So you will just pull out the -2.
Good. Okay, we'll keep that. I approve. Who gave me sine x? Why, Alison? Why sine x?
Because I was trying to get cosine out of there, and you could turn cosine squared x into 1 minus sine squared x.
Oh, I see. So you want to do 1 minus sine squared. Nothing wrong. Partially approved. What about the next one?
So you can change sine of 2x using an identity to make it 2 times sine x cosine x.
Okay.
So then in the bottom, cosine x would count as u for cosine squared, so you have u squared. And since du of 1 plus cosine x is sine x, you would be able to cancel out tops.
Okay. Last one.
Similar reasoning as my friend up here. You can use an identity to change that sine 2x into sine cosine x, or sine x and cosine x. You can pick the 2 as a constant in front of the integral, and use cosine as the u.
Very good. That identity is in the reference also. So all of these would work, but that's the easiest of all. If you recognize the identity, or if you know that you should use an identity, it's a piece of cake. Anytime you have sine, cosine, it's a dead giveaway. U is probably going to be sine x or cosine x, or you have to use some sort of an identity or put them all together. So all of those would work. Some are easier than the rest, but regardless, at the end of the day, the answer will be the same. Of course, the not put an answer to be of one type. So to get to my answer, you probably have to use an identity of some sort. So don't forget to write identities. So I'm going to go with that. The identity here sine 2x is 2 sine x cosine x. Going to rewrite my integral. So up here, 2 sine x cosine x. if I took the derivative du over dx, derivative of 1 is 0, derivative of cosine squared x is 2 cosine x, chain rule. Derivative of cosine x is negative sine x. Well, if you rewrite that, du would be negative 2 sine x cosine x times dx. If I put the denominator as u, do I get the numerator? I absolutely do, but I've got a negative sign. If I move that negative sign to the other side, minus du would be 2 sine x cosine x dx. The entire numerator is simply negative du. Bring the negative outside of the integral. Du divided by u. What is that integral? Ln of u. Oftentimes you might have noticed some like to put absolute value, some would simply put parentheses depending on the problem. Do we know why we put absolute value here? I did not.
Because you can't take the natural log of a negative number.
We can't take the natural logarithm of a negative number. So just as a convention, people would simply put absolute value, indicating that if you're going to use it in a problem, just make sure that it has to be positive. But here, it doesn't matter. Can you tell me why? Michael?
The negative is outside the
Okay.
multiply, so you multiply negative 1 by it.
By absolute, I mean absolute value of u. I didn't put absolute value sign here. Why?
U can't be negative.
Forgot your name. What's your name?
Sam.
Sam says you cannot be negative. Why can I not be negative?
Because if you square the cosine, it's going to be positive no matter what.
1 is a positive number. Cosine squared, positive number. So result, positive number. So it doesn't matter whether you put an absolute value or not. So minus ln, 1 plus cosine squared x. Let's see. Good. Would it be incorrect if I wrote it this way? Is that wrong? Think of last time. So, Sarah thought it's incorrect, and Noah said, well, it is correct, but both of them used the exact same rule, just inferred it incorrectly. So, the negative is outside, and the function that is inside the logarithm is 1 plus cosine squared x. If I can move the power of any argument that is inside a logarithm outside, I can do the reverse. So if I bring that in, I'll have that. Well, writing 2 raised to negative 1 is the same as 1 over 2. Correct? Agreed. So, if that is 2, just visualize it. I could write as 1 over 1 plus cosine squared x. Either would work. Good. Good amount of you are getting it right. Some of you still working on it, at least you know the process. Do practice more. Without practice, you're going to have difficulties. I saw 2 things as I went around. Some picked negative x squared over 4. Some picked erase negative x squared over 4. Of the 2, one of them is easy. Which one? One on the left or the right? Left. Always start simple. I have an exponential, and within that I have another function. So if I'm going to take the derivative, I'm going to end up doing chain rule. Too much work. So let's start simple and see where things go. But before I get to that, that's a negative. If it necessary, could I have used u to be just x squared divided by 4? Yes, no, maybe? Yes. Yes. You can differ by a constant, not a big deal. So let's keep it as is. Du divided by dx, derivative on that side. Negative 1 over 4, constant, stays as is. What is the derivative of x squared? 2x. What happens to 2 and 4? Cancel out. Let me not skip a step. Negative 1/2 times x, which is negative x over 2. Good. So du divided by dx is negative x over 2, which would mean du is negative x over 2 dx. Do we see this bit in the original integral? Yes or no? Yes? Okay. So move that negative du was equal to x over 2 dx. All of that would become u. Whatever that's left behind, x over 2 dx is simply negative du. Take negative outside of the integral. What is the integral of e raised u? E raised u. Are we done yet? Are we done? Yes, then?
Oh, then we just go back and.
We have to replace our substitution. Lastly, good. I add the content of integration at the very last step. Good. Now, always start simple, don't forget. One thing to know in a problem like this is a very standard problem. You'd encounter this in differential equations, shows up in statistics. Later in chapter 7, we will do integration by parts. Integration by parts is a bit more complicated process than U-Substitution. Put a star here. I'll do a similar problem when we get to integration by parts. And I'll show you that this problem can be solved using integration by parts. But it is like eating a sandwich this way, when you can eat it this way. Easier. So in chapter 7, or when you get to chapter 7 and in your future classes, you've got to make the choice. You've got to be efficient. So if you're going to make things harder on yourself, go for it. But there are easier cases, easier ways to do things. So it comes with practice, but do put that star. We'll talk about that later. Are we clear?